ALU component operation 0 for OR, 1 for AND, 2 for XOR, 3 for add, 4 for sub, 5 for borrow, 6 for invert-A, 7 for invert-B. Ignore the carry. Please only use 4-bit components where applicable, registers, gates, arithmetic, etc. Okay, first we have to choose the multiplexer based on the input. Here we have going up from 0 to 7. So it means we need 8 inputs. So we have to design a multiplexer that is with 8 input. So to derive 8 put, we have to put a 3 select bit. 2 power 3 is 8. So that's why we need 3 select bit for the multiplexer. So this is going to be an 8 by 1 multiplexer, which is going to have 3 select bit, ALU op, and it's going to have 8 inputs: 0, 1, 2, 3, 4, 5, 6, 7, 8, 1 output, and this one is 4-bit, and this one should just call this one F. Okay, and then we need to have inputs. So according to, it should be respectively, it should be following this order. And since we have 3 select bit, we can also write this one as 0 0 0 for OR, and then 0 0 1 for the AND, and then 0 1 0 for the XOR, and then 1 0 0 for the 0 1 for the add, 0 1 1 that's the add, and then 1 0 0 that is sub, and then 1 0 1 that is borrow, and then 1 1 0 that is invert-A, and then 1 1 1 that is invert-B. Okay, so let's put them in order. First we have to have an OR gate, and the second one should be an AND gate, and then we have to have a XOR gate, that's third, and the fourth one is add, so which will have a carry in and a carry out and plus sign to represent add. And then subtract, same thing but minus, carry in, carry out, minus. And we need to have a borrow. Borrow is basically the carry out from the sub, so bring a bit extender, because carry out from the sub is going to be just 1 bit, and here also 1 bit, but we only need sub. That's the carry out from the sub act as a borrow. So I bring the carry out from the sub, and you don't have to worry about this carry in and the other things, because they say ignore the carry, so don't worry about those. Only this one matter because that's represents borrow. So this is 1 bit, and we have to make it 4-bit because all the input for the mux is going to be 4-bit, and all the devices are 4-bit, and the input for the device is also 4-bit. Okay, so it should be following all that. So that's why we have a bit extending 1 to 4, and we had to choose 0, and this is a bit extender, bit extend. Okay, and that is for the 5, and then 6 we have invert-A, this is basically invert whatever the input we put for A. We are going to have two input. We have A and B, and this one is to invert whatever the value from A and then invert whatever the value from B, because we cannot do together because it's only have one input. So that's why they did it separately for the 6 and the 7. Now let's go ahead and connect them in order. So 0 should be connected with, OR should be connected with 0, AND should be connected 1, and then XOR should be connected with 2, and then add should be connected with 3, and then sub should be connected with 4, then borrow should be connected with 5, and then invert-A should be connected with 6, and then invert-B should be connected with 7. And here I made a mistake, it's only have 7 input. 0 to 7 is already 7. Okay. Already 7, and then we are gonna have two inputs, A and a B. Okay, both of them are 4 bits. Okay, and then bring a wire like this to connect with all of them. So it only goes up to this because this one we use is to invert B. So invert-A is first one only. Then this one connect here, 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 and this one should be going all the way here because we need it for this one as well. And okay, so all the inputs are 4 bits, output is 4 bits, and we follow the order like 0 should be OR, 1 should be AND, and then 2 should be XOR, 3 should be add, 4 should be sub, and 5 should be borrow, 6 should be invert-A, that is inverting whatever the value A, like for example, like when 110 selected in ALU, that's gonna point to this, and that can be controlled by using A. So if you put 4 zeros here, that's gonna turn into 4 ones, like that. Okay, and if you select 7, that's gonna choose this one, and that's controlled by this. So if you put 4 zeros, that's gonna turn this one into 1, like that. So it's gonna turn whatever in B to, it's gonna invert whatever in B, and this one invert whatever on A based on the select. Okay, and the output also should be 4 bit. We just name it as F, and that is it. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next